Start recording. Okay, now we're going to look at number 10, which we have a half-life formula, but you may not have known this when you did the problem because I didn't have you read the section apparently. So anyway, what's this problem is basically got an amount of, what is it, radium? Half-life of radium is 1,690 years. What percent of the amount present now will be remaining after A, 100 years, and B, 1,000 years? Okay, so for example, if you had 100 grams today, it would take 1,690 years before you have how many grams left? 50, half. Okay, so that's a half-life. So both these questions for A, we don't know how much is available now or how much we have now. Doesn't matter. But we want to know what percent is here after 100 years and what percent after 1,000 years. Well, I'll give you a hint. It's more than half because the half-life is 1,690 years, and that's how long it takes to reduce it by 50%. Okay, now remember, if you reduce it, let's say it reduces by 25%, what's the answer to the question? What percent is left? If it's reduced by 25%, how much is left? 75%, easy math. So you just subtract it from 100. All right, so anyway, we had a couple of brave souls that didn't have a partner here today because he's visiting a cool school like you and I, or somewhere like that. I can't really remember.
Iowa State.
Okay, or Iowa State. So anyway, what did you come up with? What did you do here?
We put 50 as the Y0.
Okay, Y0. Did you use that previous formula? Or you just said Y0 is 50, like 50 or 50%? So you just made up like 100 grams was the original, you just made up an amount?
We did half.
Yeah, we used 50.
50 was the start value?
The half-life radium. It's 50 grams.
So you started with 50 grams?
Yeah.
Or you end with 50 grams? Start?
Start.
Yeah.
Okay.
Well, where are you going?
So you're assuming 50 is the amount at the beginning? Okay. And then what?
And then we had the Y0 equal 25. Or the
20,
or the Y equals 25 to that.
Y equals 25 what?
Grams.
So you coming up with a constant. All right. So if this is like grams or, milligrams or pounds or whatever, but anyway, so this is after 1,690 years, right? Okay, and then what'd you do? Use this to come up with your constant or what?
We just put 25 equals 50 e to the kt.
25 equals 50 e to the kt, but t was 1690? Okay. And then, so basically 1/2 equals e to the 1690k, right? And then took the natural log of both sides? Is that what you did? No, what'd you do?
We got 25 equals 20 e to the 190k.
Anybody know how they did that?
Damn close.
I might rewrite this as e to the k and then to the 1690th power. Could I do that? And that equals 1/2. And then kind of doing a shortcut of what we did before, does that mean e to the k is 1/2 to the 1 over 1690 power? If I take the 1690th root of both sides, is that right? That's e to the k. Anyway, what was your equation then that you said?
25 equals 20 e 1,690k.
How do you know it's 25?
Half of 50.
Hey.
Well, right. So you trying to find k, or what are you trying to find? Like what are you doing with that?
Finding the grams, and then we took the grams divided by 50.
To get the percent.
Yeah.
Well, it'd be 50%. Because it's half.
Well,
We ended
then-
up with 96% and 66%.
Yeah, because
Okay, so how did you get it? Like, I'm not following your,
we had 25/4 equals E T to the 1,600, or T divided by 1,680.
okay. So you rewrote your equation as y equals the original amount, right? 50?
I don't think we did that.
Y0 e to the kt, right?
Yeah.
Right? Which is e to the k to the t. So could I rewrite it as y0 instead of e to the k? Could I write that as 1/2 to the 1/1690? So 1690 is in the denominator and then to the t power. So could I write it like that? Y0 1/2 t to the, or t divided by, to the t divided by 1690. And that's what the half-life formula is, and I didn't give that to you. I should have, since I was your fill-in. But anyway, so this is the half-life formula. So in general, we can do this. You developed it, and I appreciate it. You happen to choose a specific initial amount, which is fine. It works out no matter how much the amount is. But the original amount at time 0 is y0. And then 1/2 is the factor, because that's how much is left. And then t is the number of years that have passed, but divided it by the full cycle, h. H is the full half-life cycle, which in this case is the 1690 years. Okay, so we have a nice formula that we can use for half-life stuff, computations now. And then what I can do is I can take this 100 years and I can fill it in here, right? And basically it's a percent. So if you're using 50, that'd be fine. If you were picking a number, I'd probably pick 100. Be a little bit easier because then it'd be a percent. Okay. But anyway, does that make sense? Do you care if I do that? Can I change these since you're doing that? Can I just make it 150? Okay, because 100 would be 100% is here now, and then whatever number you get for y at the end is the percent that's left. Correct? I believe it's the percent that's left. So for part A, we've got y equals 100 times 1/2 to the 100 divided by 1690, right? And what's that equal?
47. Yeah.
96%.
So this is 0.96 is what you get here.
Yep.
So it's about 96%. Okay, so if you don't know, you can go nearest 1/10 of a percent, but we should have most of it left, right? Shouldn't we have most of it left? Okay, so anyway, by the way, if you didn't put anything for y0 and just kept it y0, you know, the original amount is y0, you'd still end up with this factor. So you don't have to put 50 grams in or a specific number of grams in. You don't have to do that at all. But it is proportionate, so it works out. So how does the second equation work out for us then? So if it's 1,000 years, we plug that in for t. And so you'd have y equals 100 times 1/2. It's easy once you have the formula, right? To the 1,000 divided by 1690. And what'd you get for that?
66%.
Okay, it's about 0.66 or 66%.
So are you starting with 100 grams or 100?
Well, I did. I changed it. They started with 50. So they would have had a 50 here and a 50 here.
Yeah.
And then they would have got a different number there, and then you had to do the math. You would have had to do the math, right? So starting with 100 grams is easier. But if I would have just called this A0 for the, or Y0 for the amount at the beginning, and just had Y0 here, then I'm going to come up with a proportion. So you don't have to choose a specific amount to start since it wasn't given. But if you do, you probably want to pick 100 because that tells you the amount that's available at the end. And then we also did number 16. Can we just run through that quick?
Yeah,
Yeah.
for 16, we've got 0.5 equals 1 to the E.
Well, let's talk about what the problem is first, because remember, I'm live on video.
Oh, shoot.
So if the purchasing power of the dollar is decreasing at the rate of 10% annually compounded continuously, how long will it take the purchasing power to be 50 cents?
So the purchasing power of a dollar purchasing power is going to be worth 50 cents, or to keep the labels the same, $0.50. That would be better, right? You either have 100 cents and then 50 cents, or $1 and $0.5. But it's reducing at a rate of 10% per year,
4.1.
right? And you want to know how long?
Yeah.
Okay. And so we have a money equation. So here's our money equation. My green marker doesn't work anymore. But the money equation for compound interest, okay, I'm just going to use the one that I know, but the principal at the end is the original, or the amount, excuse me, the amount at the end is the original principal e to the RT power, where R is the given rate. Okay. PERT. So there used to be a shampoo called PERT Plus. I used to use it when I was a kid. So anyway, it's just probably cheap shampoo my mom would give me. Anyway, so PERT, that's how I remember that. Now this book uses a little I for the rate per period instead of an R. So R is probably, annualized rate. So if it's, 12% per year, then it'd be 1% per month. It'd be the rate per period. But anyway, it gives it as a per year period anyway. So little r and little I are the same thing in this case for the rate. So that's 0.1. So it's e to the, now wait a minute, it's negative 10%. So what did your group do?
Negative 0.1.
So it's down is a negative, right? So it's minus 0.1 is the rate for the year, which is little r. So it's the principal at the beginning, that's the amount at the beginning. A is the amount at the end. So what do we have? Let's just rewrite this. 50 cents, so 0.50 equals the $1 times e to the r, which is minus 0.1 times t, and t is what we're looking for. Now what's nice is this 1 times that. 1 times 7 is what? 7. So 1 times x is just x, right? So I can really ignore that, and I get 0.5 equals e to the minus 0.1 t, right? So how do I solve for t?
Take the natural log of both sides.
Natural log both sides, okay?
LME is just 1.
So that's 1. So on the right side, it's minus 0.1 t. On the left side, 0.5 is a half. I'm gonna rewrite that as natural log of a half, which is natural log of 1 minus natural log of 2. What's the natural log of 1? 0, right? So minus natural log of 2 equals minus 0.1 times t. And to solve for t, divide both sides by negative 0.1. Okay, which means I multiply it times 10. So 10 natural log of 2 is t. That's the exact value. Of course, it's years, right? So what is 10 natural log 2 approximately? 6.93 years. Now, I will give you a thing called the Rule of 72. Tells you how long it takes your money to double. It's called Rule 72. Take 72 divided by the rate as a whole number, and that'll tell you the number of years to double. This is an approximate. It's somewhere between compounded annually, which is what this problem is, and compounded quarterly, because the more times you compound it, the bigger impact on your money. But anyway, so if I'm looking for the number of years and the rate is, well, what I got, number of years for it to double. So I can go the other way on this Rule of 72 and like, hey, how many years for that 50 cents to $1, assuming I got 10%. So it'd be positive 10% per year, right? So 72 divided by 10 is what? It's about 7.2 years. Is that close to the answer that we got?
Yeah.
It is close, like I said, this is the rule of 72 is an estimate. It tells you how long on a going forward basis with a positive rate of return it takes your money to double. So if you have $100 today and I get 7.2% return, about how many years before that $100 becomes $200? If you done
Say that again.
7.2.
7.2% return on $100, how many years? 72 divided by 7.2 for the rate of return, it would take about 10 years for your money to double. There you go. Ready, break.
All right.
Let's go do some fun stuff.